Okay, grade eights, welcome back. This is assignment number 6 we're up to. This one's on dependent events. Last time we did independent, today we're going to do dependent. We're going to talk about marbles a lot today, hence the picture. All right, let's get right to it. Dependent events, remember what these are? We talked about it last time. Dependent events are events where one event occurring impacts the probability of another event occurring. So last time we talked about independent events. Those are where one thing doesn't impact the other. Like you flipping a coin and then rolling a dice. It doesn't, whatever you get in the coin doesn't impact what you get on the dice, right? But with dependent events, one thing does impact the other. All right, I'll give you an example from real life. Let's say that you came 20 minutes late to math class. Does that impact the probability of you learning that day's material? Yeah, it does because you just missed 20 minutes of material. Those events are dependent on one another. But you coming 20 minutes late to school, to my class, you coming 20 minutes late to class, does that impact what I'm going to have for lunch? No, my lunch is already made. Well, actually, usually I don't have lunch. But anyway, no, that does not impact my lunch. So those are independent events. All right, usually with probability, we talk more about coins and spinners and stuff. So here's an example. Cards. If you pull a card from a deck, then pull another card, that's dependent. Unless you do what? Unless you replace the first card, then it's independent. But if you pull a card, don't put it back, and then pull another card, that's dependent because you've changed the probability by removing one card from the deck. I mean, think of it this way. Instead of there being 52 cards in the deck, there's now only 51 when you pull the second card, so your probability is going to be different. So if there's no replacement with cards or with marbles, blocks or whatever, if there's no replacement, then it's definitely going to be dependent. Okay, we're going to do one example. There's 5 questions, or 6 or 2, 4, 5, but it's just one example. It says a bag. Okay, I'm sorry. I'm going to inflict upon you once again my horrible bag that I always draw. It's the same every year I teach math, which has been many years. I always draw the same bag. They're awful, I know. It says a bag contains 4 red marbles. Okay, I'm going to draw these lovely red marbles floating in the bag. But, it's just easier to see this way. 3 blue marbles. 1, 2, 3. I should just speed through this. Do you really want to watch me do this? 2 white marbles. What was I thinking? I can't draw white. So this is my white marble, okay? And 1 yellow. That's dumb too. Yellow doesn't show up very well in this thing. All right, so there's my marbles. And then what I'm going to do is I'm going to pick some marbles. I'm not going to replace after each pick. And I want you to tell me what's the probability of picking out the following marbles. So the first situation is to pull out a red and then a white. Okay, so the first thing we have to do is to figure out what's the probability of pulling out a red on the first pick. What's the probability of pulling out a red? All right, so how many total outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 marbles on there. So it's going to be out of 10. How many favorable ones are there? Well, those are all the red ones. 1, 2, 3, 4. So it's 4 to 10 probability. Hey, let's put it in lowest terms. 4 to 10, 2 out of 5. Okay, the next thing we have to do is we have to figure out what's the probability of pulling out a white one. Probability of getting white. But hold on a second. Remember what we just said? We said we want to know what's the probability of getting red first, not replacing it, and then white. So you have to think, if I reached in here and did pick out a red, it doesn't matter which one that you pick, but pick one of them. I don't know, I'll pick this one. Oh no, don't tell me. I'll reach in and take this one. I'm sorry I have to do it this way. And I'll redraw it out here. I've removed it from the bag. So that happened. Now I want to know what's the probability of also getting a white. So we do the same thing again, same probability exercise, but we don't have 10 marbles in here anymore. Now we only have 9. Our total outcomes is 9. How many of them are favorable? How many are white? 1, 2. 2 over 9. Okay, so what we want to know is what's the probability of getting a red one, which had a 2 and 5 probability, and then getting a white one, which had a 2 and 9 probability. Do you remember from last time what to do when you have 2 events and you want to know what the probability of both of them is? You multiply. We are going to multiply those together and we get 4 out of 45. That's already in lowest terms. We are done. So the difference isn't the multiplying. We did that last time as well. The difference is when we remove something from the bag this time, we don't put it back in. Last time what we did is we removed the red, but then we put it back in before we did the white one, so it would have been 2 out of 10 again, right? By removing the red one, we change the probability of the white one. And in that way, this is a dependent event. All right, let's go back to the original situation and we'll do this question again, or do a new question. So this one says take out a blue and then take out another blue. All right, well, so the first thing we need to know is what's the probability of getting a blue? So total number of outcomes, well, we're back to the original when there was 10. Total number favorable, those are the blues, 1, 2, 3 of them. Okay, that can't go into lowest terms. It's already in lowest terms. So we're done. Now I want to know what's the probability of getting another blue. But remember, we picked a blue. Now at this point, some people always ask questions. They say, well, what if you didn't pick a blue? Well, that's possibility. But what I want to know is what's the probability of getting both blues. So you have to assume that you did pick one of the blue ones. Darn it, they're all going to leave again. So I'll get rid of a blue and redraw it here. I did pick a blue. It doesn't matter which one of the blues I picked, but I picked it. I'm not replacing it now. Now I need to figure out what would be the probability of me getting a blue this time. Again, it doesn't mean I am going to get blue. It means what's the probability? What are the chances that I get blue? So how many are there left in here as our total? There's now only 9, right? One of them's out, so there's only 9 left. How many are favorable? The 2 blue ones inside are still favorable. So we have 3 out of 10 for our first event. We have 2 over 9 for our second event, and what we do is we multiply. Oh my gosh, you know what would be beautiful to do right here? I would love it if we did some ninja slicing. Look at this. 3 and 9 become 1 and 3, because we can divide them both by 3. 10 and 2 become 1 and 5, because I can divide both of those by 2, and I'm good to go. 1 times 1 is 1, 5 times 3 is 15. Oh, if you can remember your ninja slicing, it will help you out in this section. If you didn't do that, of course, you would have gone 3 times 2 is 6, and 10 times 9 is 90, and then you would have had to put it in lowest terms, and you would have gotten 1 over 15. Okay, let's keep going. Red, and then white, and then yellow, and then another blue. Oh my gosh, we have to do 4 of them this time. Let's speed it up a little bit. All right, so we have to pull out a red to start. Well, I think we know what the probability of that is. We did it up here. But just to be complete about it, probability of getting red. There's 10 in there to start. How many of them are red, are favorable? 4 of them. So it's 4 over 10 or 2 out of 5, just like we had up here. Okay, next we want to know what's the probability of then getting white. Wait a minute, we did that in the first question too. These are bad questions. I have no one to blame but myself. I made them up. So I'll get rid of one of the reds. It doesn't matter which one of the reds I take out. Again, I know what some of you are saying, but what if you didn't pick the red? Well, then you didn't do what we wanted to know about. We wanted to know what's the probability of doing all this, red, white, yellow, blue. And the only way we're going to find that out is if we assume you did pick out a red and assume you did pick out a white. Doesn't mean you will. We're just figuring out the probability of you doing it, the chances of you doing it. Okay, we took out our red. Now we got to figure out our white. So how many are left in there right now? There are 9 of them left in there. And how many of them are favorable? How many of them are white? 1, 2. 2 of them are white. So we got our 2/5, we got our 2/9. Now we got to figure out the probability of getting a yellow. Notice you must do them in order. Okay, next time we'll talk about changing order and stuff, but you must do them in order for today. So we got to get rid of one of our whites, right? We picked a white. Again, I got to do it this way and redraw my white out here. So the probability of getting yellow. What's our total now? We've gotten rid of the red. We didn't replace it. We got rid of the white. We didn't replace it. How many are left in here now? There's 8 of them left in there. How many of them are favorable? In other words, how many are yellow? 1. And that's it. You can't put that in those terms because it already is. All right, so we're going to get rid of that yellow. And now we want to know what's the probability of getting another blue. So how many are left? 1, 2, 3, 4, 5, 6, 7. For the total, we're down to 7. How many of them are favorable? All the blue ones. That's 1, 2, 3. Why does it say another blue? There's only one blue. Oh my gosh, I did this too fast. Okay, so then the probability of getting blue is 3 out of 7. So we have 4 fractions here. We have 2 over 5. We have 2 over 9. We have 1 over 8. and we have 3 over 7. And what are we going to do with all those? We are going to multiply. Do you see some ninja slicing that you could do over this with this? This is a 5. I see some ninja slicing. I see the 9 and the 3, which could become 1 and 3. I see the 2 and the 8, which could become 1 and 4. And I also see the 2 and the 4, which could become 1 and 2. That will make it a lot easier if you can do that rather than multiplying this all out and have to put it in lowest terms. 1 times 1 times 1 times 1 is beautiful. It's 1. 5 times 3 times 2 times 7. Well, I'm going to do it this way. 3 times 7 is 21, and 5 times 2 is 10, and 21 times 10 is 210. So it's a 1 in 210 chance, not likely. Of course, you could use calculators to do this, so that's fine too. All right, what do we got now? Yellow, and then blue, and then another yellow. Okay, if you think about this, you already know the answer, but I will do this because I want to make a point here. Okay, so back to the original. We want to know what the probability is of getting yellow. So I'm going to write probability of yellow. I'm just going to set this up. We want probability of yellow, probability of blue, and then probability of another yellow. Again, some of you are probably screaming, stop, stop, I know the answer. But what the heck, let's do it. Probability of yellow, how many total are there? 10. How many yellows are there? 1. So for our first one, it's 1 out of 10. Okay, we got to do blue. But remember, we did pick the yellow. We're assuming we picked the yellow. So now we're doing blue. How many total are there in here? 9. How many of them are blue? 3. So we have 3 out of 9. Oh, wow, 3 over 9. I like that. We can put that in lowest terms. 1 over 3. Okay, so we got to take one of those blues out. And now what we're asking is, what's the probability of getting another yellow? So let's see, how many are left? What's our total now? 1, 2, 3, 4, 5, 6, 7, 8 is our total. And how many of those are favorable? In other words, how many of them in here are yellow? None. It's a 0. That's totally possible. It's impossible to pull out that second yellow. I hope you know what your final answer is going to be when you multiply 1/10 times 1/3 times 0 over 8. Look what you get in the top. 1 times 1 times 0 is 0. I don't even care what you get on the bottom. Well, I'll tell you, it's 240. 0 divided by anything is 0. Now remember, what does probability of 0 mean? It means impossible. Why is this question impossible? Because you can't pull 2 yellows out when there was only 1 yellow in the bag to start with, right? So there you go. It works even in ludicrous situations like that. Okay, last question. What's the probability of picking one blue, then another blue, and then another blue? So super fast, let's do this. Probability of blue, and then probability of blue, and then probability of blue. So to start, how many marbles are there in the start? 10. How many of them are blue? 1, 2, 3. Okay, so we have 3 out of 10. Let's get rid of one of the blues. There we go. So next blue, we want to get for the second blue. How many marbles are in the bag? 2, 4, 6, 8, 9. And how many of them are favorable? How many of them are blue? 2. So we have 2 over 9 for our second one. We've got to get rid of another one of these blues. So I'm going to erase and redraw it out here. So I only have one blue left. Okay, so we want to get the probability of getting that third blue. How many total are there in there right now? 2, 4, 6, 8. And how many are favorable? Just the one blue. So 1 over 8. Great. What do we do with these three probabilities? We multiply them. Let's look for, oh, I'm using dots this time for my multiplication. It actually is my preference. Let's look for ninja slicing. Oh yeah, ninja slice here and here. 1 and 3. Ninja slice here and either one. Don't do both, either one. You do one on top, one on the bottom. I'm going to do this one. I like multiplying by 10, so I'm going to do this one. So I get 1 and 4. Hey, we keep getting the numerator of 1. 1 times 1 times 1 is 1. 3 times 4 is 12. Times 10 is 120. The chances of pulling out all three blues are 1 in 120. You'd probably have to do this about 120 times before you got all three blues in a row. All right, that is dependent probability. So here is your assignment. It's a worksheet. In fact, it's the same worksheet I gave you last time, or at least it's the one of the pages I gave you last time. It's numbers 16, 18, and 20 from the same worksheet I gave you last time. I'll send it to you again, but you're more than welcome to do it on the same worksheet that you did last time, or you can print it off again, or whatever you're doing to do your questions. Let me know if you need any help. I'm here to help you, and happy to do video chat with you or whatever you need. Otherwise, take care and stay healthy, people. Bye.